Hello students and welcome to the lesson on trigonometric inverse functions. And before we get into trig inverse functions, let's just review a little bit what a regular inverse function. So an inverse function is a function that swaps the input and output. So for example, if I have f of x here that maps 5 to 10, 8 to 13, and 2 to 7, f inverse of x is going to take all these arrows and essentially reverse them. So the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original function. And you can see here it reverses all these directions. So 5 used to go to 10, well now for f inverse 10 goes to 5, 8 goes to 13, now 13 goes to 8, 2 goes to 7, 7 goes to 2. This is a typo here. This should say 2. Excuse me. So let's look at the graph of inverse functions, and this is also a review. So if I plot all these points here for f of x on the graph, and then I can plot all of the points for the inverse of f, or f inverse, you can see that it is symmetric over the y equals x line. And really that's how a inverse and its function are related graphically. So now let's look at trig functions. I have the sine function here, which is in blue, and sine inverse is really the sine function reflected over the y equals x line. So if I take that and I reflect it, I get this red line here, that's sine inverse. But you see that sine inverse has a problem. It's not really a function. It actually fails the vertical line test here. So if we want it to be a function, and then we have to modify it a little bit. So we'll just do this by restricting its domain and its range. So you've seen this before, where a sine function or when you've seen this before when any sort of function has a restricted range or a restricted domain. And you ask, well, why do we pick this section? Why don't we just pick something up here? Well, this is really just a matter of mathematical convention. It's probably more convenient to pick the one that's near the origin. So that's what mathematicians have done. And this right here, this red curve right here, is the sine inverse graph. Now let's compare the two. Sine of x has a domain of all real numbers, a range from -1 to 1, because that's what the that's basically the radius of the unit circle that's driving that, and intercepts at 0, 0. Sine inverse then, for its domain, has the range of sine. For its range, now it's a little bit different. It doesn't quite go all the way up to -infinity and positive infinity. It is restricted at -pi/2 and pi/2. And then finally, the x-intercepts and the y-intercepts are still the same. So let's look at this again, but this time with cosine. Play the same game or the same activity that we did before, where we take cosine, reflect it over y equals x, and you get this red curve right here, which once again is not a function because it does fail the vertical line test. So if you want to make cosine inverse, well, you have to restrict its domain and its range. And so cosine inverse looks a little bit like this. It's a little bit unusual. And let's compare. Cosine has a domain of all real numbers, a range of -1 to 1. The x-intercept is actually pi/0, and the y-intercept is 0, 1, or one of the intercepts. There's a lot of x-intercepts here. For the cosine inverse function, you have a domain at -1, from -1 to 1, so that's the same thing as the range of the cosine function. Now the range, once again, it's restricted. It inherits a restriction, so it doesn't go to -infinity and positive infinity. It goes from 0 up to pi. The x-intercepts, and you can see that the x-intercepts and the y-intercepts are somewhat reversed from the cosine function. So the x-intercept here actually occurs at 1, 0, and the y-intercept occurs at 0, pi. And so there you have it, a little bit of a graphical representation for the cosine inverse and the sine inverse function. What we're going to do next is do some problems that illustrate this concept better, but for these lessons it's sometimes helpful to look at things graphically first before we look at it from an algebraic standpoint. Thank you for watching, and have a wonderful day or a wonderful evening.